Hello, hello, can you hear me online? Testing, testing, 1, 2, 3.
I never used the C-Line system. Maybe just can.
Woohoo!
Someone
Excellent.
more experienced in C-Line can have it. But because yeah.
So we're just doing the exercise at the moment. Normal service will resume shortly.
We just a simple plus, and it turns a new string. You do any other programming Python? It's not that far away from
it's not that far.
Yeah, yeah, exactly. But in Python you have yeah, exactly. You don't have the type system yet, which is nice. And certain the variable change the type of the same. It's interesting.
I do. We're actually going to spend quite a lot of time doing this for everybody next week. Yeah, so if you okay. I've got the files. Let's have a look. Usually it comes up and it asks you to set it to
maybe I've done
add tool change, right? Let's add a tool change. So do you have a compiler installed? Right. That's something we need to fix first of all. So do you mind if I just don't worry, I'm going to get this around up next week. We're just getting ahead of small one? We just let that look so you need to kind of say choose where to put it.
It doesn't matter.
We'll find it. Just let it do its thing. It needs to come in. But anyway, what you need to do after that is in here, navigate to the once it's finished decompressing, navigate there to the directory where you installed it, and then it should be able to detect all these variables. And after that, the next exercise I'll have another go.
this word here, but it's the first word I typed. If I want to store more words, I have to keep What do you mean?
What so long as I so it's very you use
Yes. I didn't need to include string. Is that because I've got
yeah.
where?
Okay. Oh, silence descends. Okay, so I think most people either got there or saw somebody's working solution. This is my solution. So, so what we've got here, we've got this. We declare a function called say hello. This function returns a type std : string. So one of the things I caught when I was going around is, why do I have to have this horrible std : prefix? Can't I just say string? That'd be much nicer. In some ways, maybe. So we're going to talk about it again in a couple of minutes, but string is a library type. It's not built into the language. It belongs to the standard library, and everything in the standard library has this std prefix, std : Now there is a shortcut you can use. You can say using namespace standard. You'll see it in a lot of examples that lets the compiler look in the standard namespace if it can't find the thing you're referring to. It's generally considered best practice not to use this line, because the standard library has a ton of stuff in it, and you're going to end up finding names you really didn't intend to. So for my examples, I'm going to explicitly write it. You will find within a couple of weeks of using C++ that your fingers can type std : without even thinking. Like you just do. So yes, this is a function say hello. It returns a standard string. It takes one parameter of type standard string, and the name of this parameter is name. Curly brace opens the definition of this function, tells the compiler what the function does, and this function returns hello plus name. So for standard strings, it's got this plus operator that can join two strings together and returns you a new string. So this is saying return this new string with hello plus name from this function. And we move down here, we declare another function called main. Now if you remember from last week, main is a very, very special function. It's where your program begins. Has to have return type int. And within this function, we've got standard cout, which is this horrible way that C++ has of printing things, because saying print would be too easy. So we have standard cout, and then we stream the return type of this function into cout. So what we're doing here is calling this function, invoking this function. So we give it the argument in brackets, and the argument I'll give is Tristan, because why not? Had to pick a name. So we're passing it the name Tristan. So the compiler then looks up here, and it puts Tristan into this variable, which is uncomfortable. There we are. Puts Tristan into this variable. And then it executes this line of code. It says return hello plus Tristan. And then if you run this, what the compiler will do, what the computer will do, we'll stream hello Tristan, so the return of this function to standard cout, and then it'll add a new line at the end. So as I said, I think, just looking around, quite a few people got that? No? No? Which bit's giving you trouble?
It's the syntax.
The syntax?
Yes.
Yeah? Which syntax part?
STD.
Yeah.
Is it STD that's bothering you?
If you use the C line stuff, it has the namespace automatically.
It has using namespace standard? Oh,
I
boo.
just found it on the first second.
Okay.
I've been using
Yeah. Okay, bad habit. Don't do it. Because when you write a real program, we're doing sort of little examples at the moment. If you start using a program with thousands of lines of code, you're going to find you're using libraries from lots of different places. You're using other people's code, because that's how we build programs in real life, right? We use other people's libraries. And what namespaces allow you to do is to use the same name, to have the same name, but in different namespaces, and they don't clash. So there might be another library that defines its own kind of string. It'd be a silly thing to do, but they could do their own thing. So then we'd have other : string, or whatever the other library happened to be. But if we just use using namespace standard, and using namespace other, and using namespace this, that, and the other, and suddenly we've got a whole list of using namespace, and we don't know which library type we're referring to. So if we explicitly write std : we're saying it's definitely standard string. No other kind of string. And there are other reasons that Rich is laughing over there because he knows what ADL is, but there we are. There are very good reasons to use std : Yeah.
How high level languages manage this program?
So in Python, for example, there are two ways of importing a module. So you can either import, you can do from module import star, which just imports all your names into the global namespace. But again, in Python, that's seen as being quite a bad thing to do.
Why?
It's bad.
It's bad.
Because you clog your memory for no reason. Maybe you have a big module, I don't know, random, you only want to run int. You can bring in memory a lot of stuff for nothing. Instead, you just go surgically, open your drawer, and take everything that you need.
Okay.
So, yeah. So in other languages, they don't use double colon, they usually use a dot. C++ is kind of unusual. But in C# or Java, you'd use a dot. So you'd say package name dot type. And that way you wouldn't get the name clashes. Again, in Python, you use module name dot what the name is, right? So this problem occurs in lots of languages. Probably the only one it doesn't is in C, because you don't have namespaces in C. Everything's in one namespace, so you have to prefix all your functions and all your types with a string that rapidly gets messy and involves a lot of typing. So yeah, std, : I can see where you're coming from. It's really annoying having to type it everywhere. But there is a reason for it. And if you really want to, when you're just doing your own code, just trying something out and you just want to do it quickly, you can do using namespace std and then a semicolon, and that says, okay, just let me write everything in here without this silly prefix. But just be careful when you're doing that, because other people might bark at you and tell you, no, don't do this. Particularly if you go on Stack Overflow. They will really... Anyway. So this is for standard library types. But there are other kinds of types built in to the language. So int is a built-in type. We don't have to say std : int. It's built into the language. So there are a wide variety of types built into the language. For example, we have this thing. How would people pronounce that? Char? Okay, well I say car, so deal with it. So car, character, it's a single ASCII character. So for those who know about Unicode, this is not that. This is 1970s, so you've got a very limited character set, basically only the ASCII characters, so lowercase English letters, uppercase English letters, numbers, and a bit of punctuation. But car is basically the very basic character type. Another one is bool. You'll be using bools very frequently. Yeah, I like them too. A bool can have one of two values. It can either be true or it can be false. By the way, all the things in blue on my slides are keywords in the language. So these are things you're not allowed to redefine for yourself. The names you're not allowed to use. And if you try and use them, you'll get in trouble. The compiler will get very, very confused. So bool is a Boolean. It's true or it's false. Again, pretty common. Most programming languages have something like that. Another one you'll be using everywhere. You've already seen it in most of the examples. In int. This is an integer. Here's a little asterisk is because I'm sort of weaseling about. On every computer you are likely to use, an int is 32 bits. That's 4 bytes. Means it can hold any value between, what is it, minus 2.1 billion and 2.1 billion. Technically, we'll see in a minute, the C++ standard doesn't say how big an int has to be, which is a bit annoying. But on every mainstream computer, it's going to be 32 bits. Those are integer values. Those are whole numbers, positive or negative. We also have floats. A float is a number that can be a fraction. And this, for those who know what this means, this is a single precision floating point. We also have doubles, which is a double precision floating point. Again, the 32-bit and the 64-bit, for all practical purposes, those are the sizes you're going to get. And what this means is that a double can hold a much more accurate representation of this, what in mathematics we call a real number. So when to use float and when to use double? Most of the time you probably want to use double. The only problem is it uses twice as much memory. But it holds a much more accurate value. So,
Is there a speed disadvantage?
Is there a speed disadvantage? That's a good question. Those two are nodding, and they do games programming, so I'm going to go with yes. I have heard that on 64-bit systems you get pretty much the same performance with floats, with doubles, but no.
Pretty much the same as not the same.
Pretty much the same is not the same. Floats are faster, I think is what we're getting at. Yeah, doing operations, doing heavy numerical work on floats is going to be quicker, but less accurate. So there we are. so these are the ones that you'll see come up in lots of examples everywhere. But they're by no means all of them. In fact, C++ has an enormously wide variety of integer types. So this is the most basic one. This is the easy one. This is the one you'll be using all the time. However, you may see in examples a lot of other types. In fact, it has all of these. Char, which is technically an integer type, although as we've said, it represents a character. You can have a short int, a normal int, a long int, and a long int. And each of these is at least as big as the other one, which is not a very helpful definition because it doesn't actually tell you what sort of values these things can hold. This isn't even all of them. These are the signed ones. You can also have unsigned varieties of all of these ints. So you can have an unsigned short int, and an unsigned int can only hold positive values. So that gives you double the range. So instead of plus and minus 2 billion, you can now hold 4 billion, 0 to 4 billion. So it gives you a slightly different range. And there are a couple of other minor differences between unsigned and signed as well. Oh, and we can explicitly say that we want a signed int. So I haven't included it here, but technically you could request a short signed int or a long signed int. But people usually don't bother because it's implied. If you leave it out, the default is you get a signed one. But technically signed is a keyword in the language. And finally we could omit. So for the names of short, long, and long, you can omit this int parameter, the int part of the name, and just say short, long, or long. And that's also true for unsigned int. You can just say unsigned. Yeah.
If I don't put a sign, there is some ambiguity, some compiler might put a sign, or by default every compiler has
Okay, so for everything except char, you will get a signed integer.
Okay.
Char is a bit funny. Basically, don't worry about it. Char might be signed or might be unsigned, but basically you're always going to be able to store the basic character set, which is really what you want to use a char for. A char. Even I can't say it consistently now. When I'm reading code, the voice in my head always says car, and now I'm saying I'm out loud and it's coming out char. Sorry.
So if I wanted to store something which is an extended ASCII code, I should use some trick or...
What do you mean by extended ASCII?
You know, like the characters code which requires 2 bytes, so this kind of stuff.
So Unicode strings, that's a bit of a mess in C++, but there are 2 extended character types that I haven't bothered talking about here,
Okay.
but there are larger character types that can hold.
Built-in or?
Sorry?
Built-in?
They are built in. So there's car 16T and car 32T. So if you are very interested, you can go and research those. Anyway, the whole point of this slide was to tell you declaring integer types in C++ is a mess. Because, like we said, the standard doesn't even define how big an int is, let alone the rest of the types. The only guarantee it gives you is that an int can hold every value that a short int can, and a long int can hold every value that an int can, and so on. It doesn't tell you how big these things are. It's a bit of a problem. And it's a particular problem. This isn't just an academic thing. So the type long, or long int, or signed long int, depends how verbose you want to be. On Windows computers, that's 4 bytes. And on modern Linux systems, 64-bit Linux systems, it's 8 bytes. So this is a real-life problem with long that actually comes up on real systems. Fortunately, we have a way around it. We have this header called C standard int, C stud int. What? No, this is good. This is good. Yay! So we can have this thing. We can say, I want an unsigned int of 16 bits. Or I want a signed int of 64 bits. And only for these, not for strings, but for these special fixed size integer types, you're allowed to omit the std : : You don't have to type it. It's optional. You can put it there if you want, but you don't have to. You can just say, in this example, uint32t. So this is an unsigned integer of 32 bits, 4 bytes. So these aliases are very, very commonly used, particularly in code that has to work across a large variety of systems, because these are guaranteed to be the size that it says there.
Again, is that good practice to just use regularly if you expect to see it in quality code?
Yes. So my recommendation is for everything except a basic int, prefer using the sized aliases. So yeah, it's pretty unusual to see long in real code because people will prefer to say int64t, not only because it's less to type, but also because you know for definite what size that is. So it gets around this horrible portability mess that we've got ourselves in, which, by the way, isn't C++'s fault, this is C's fault. C++ has to be compatible with C with these types because they all come from C, and C refuses to define what they are, so C++ can't either. So yes, they're all the fixed size aliases, so there's 8, 16, 32, and 64, and there's unsigned and signed varieties, so either with the U, meaning unsigned, or without, meaning signed.
What is the T on the end?
The underscore T just tells you that it's a type. That's mostly, I think, just so it doesn't clash with other people's code who have omitted this T, because these are a much later addition to the C standard than earlier versions.
Why do you give it 0?
I just picked a value.
Obviously, you can put any number, it will still work.
As long as it fits into the type, yes. So you couldn't have a 16-bit value can store, what have I said there, uint16, so it can store things between 0 and 65,500 and something. So if I tried to say uint16t u equals 10 million, well, that's not going to work. That's not going to fit into this type. But yes, 0 was just the first value that came into my head. So we've talked about, those are some common built-in types and aliases for built-in types that make things a bit easier. The other one that you'll be using frequently, you already have, in fact, it's standard string, std string. So this is one of the wide variety of types that the standard library gives us, with which we can build our own programs. So most languages have, many languages have a built-in string type. C++ doesn't. And the reason it doesn't is that it's one of the sort of principles of the languages to give you the tools to build these things yourself. So you, if you wanted to, could write a string type. In fact, in years gone by, almost everybody did write their own string type until they came up with this standard string thing. So a standard string behaves roughly like an array of chars, characters. So an array is just like a collection, a sequence of things. So a string is basically just a sequence of characters. Does that make sense? I see some nodding. That's good. And as you've already discovered, in order to use this, because this comes from this standard library, you have to include a header. The header in this case is quite easy to remember. It's just string in angle brackets. We're going to talk a lot more about headers and includes next week. Does that make sense?
Yeah.
Other than having to type std : which people don't like. There's one other type that will turn up in several of our examples. It's standard vector. So a vector is like a collection of some other type. So we could have a vector of ints, or a vector of floats, or a vector of chars, or a vector of bool, or whatever we like. Don't use vector of bool, actually. We can put any type, almost any type, into a vector. And the reason for that is because it's what's called, it's a template. So if you've used other languages, like Java or C# or whatever, then templates are a bit like generics. So the way we do that is we put the type name that we want a collection of in these angle brackets. So we say standard vector of int, and in this case I've named it intvec. Or we can have a standard vector of standard string. You see why your fingers get very quick at typing standard, don't you? So again, this is the same syntax that Java and C# use for generics, because they inherited the syntax from C++, actually. So this means we want a vector of ints.
I'm confused with it. How do you have a vector of string? That's the magnitude and direction.
No, okay, so this is not a mathematical vector.
Oh,
Okay, so I don't actually know why it's called vector, but it's what other languages call a list or an array list or something like that. I understand the confusion. Yeah, it's not a mathematical vector. It's not a magnitude and direction. It's just the standards name for a growable array of something else.
okay.
A container, yeah.
You don't have to to declare the size
Of a vector, no, you don't. No.
so there is no like if I think what is said about the int, there is a space problem. So you have to.
No, there's very good thinking.
I don't know.
No. I know where you're coming from, and it's a very good question. Okay, so what vector does, it is actually behind the scenes, behind the curtain, it allocates memory from the operating system. It says, please, can you give me enough room, enough memory to store some ints. And then you can add things to the vector. And as you add things, when it runs out of space, it'll go to the operating system. Can I have some more memory, please?
Okay. You have VIP there.
Sorry?
Basically, you do what you want. Like,
Yeah.
You put everything that you want there.
Yeah, you can add as many things as you like to a vector till your computer runs out of memory.
Okay.
Yes?
Intvec and stringvec are just the name.
They're just the names of the variables.
And it can be anything.
They can be anything. So we're going to look at variable definitions in just a couple of minutes, in fact. So I had to choose which order to do these things in, whether to introduce the types or whether to introduce variable declarations first. Either one, so the examples rely on the other, so yes.
Yeah, I think you're going to say later, but what's the point of vector? Like, just like declare int or
Okay, so let's say Tom wants to write an email to everybody in the class. Okay? But we've got a different number of people here than we had last week. So we need some sort of way of collecting together all the names of all the people in the class. So a good way of doing that would be to have a vector of strings. So a vector is like a collection, a container of strings. So we can put as many strings as we like into it.
Oh, okay.
Okay? And then later on, we can go through the vector and we can say, do something for every string that's in this vector. But that's next week. So templates, I already said that. Templates are a bit like generics in Java, a little bit sort of vaguely similar. Similar idea anyway, very different in how they work. But we'll be using vector a lot more. This is just because if you go looking online, pretty much every beginner tutorial will tell you to use vector pretty early on. So I didn't want you to be very surprised by what it is and wonder about what it is. There's a very good question you raised about the mathematical vector. I'm so used to seeing this, I'd even forgotten the mathematical meaning.
Especially when you said standard vector int.
Yes.
So that was the
Yeah,
two,
no,
three,
you're
four.
absolutely right, yes.
If you tried to put something in that was of a different type, how would it let you know?
It would say, no, you can't do this.
Like when you compile it or something?
Yes, exactly. So if you had a vector of strings and you tried to put a double into it, the compiler, the point when you do that, it's going to say no. No, and it's going to give you an error message. It's going to say, I don't know how to... Actually, what it's going to say is, I don't know how to convert a double into a string. So this is the whole point, in fact, of these templates is because it gives you this type safety.
How far can the compiler go in determining what's going to go into a vector at runtime?
You mean how much space does it reserve?
No, I mean when it's you probably get. I'm just trying to figure out. You probably get some errors or some way of saying there's something wrong at runtime in some instances because the compiler doesn't run through the code and go, oh, now, like if you're doing some form of iteration over the for loop or something, the compiler doesn't do the job of running through the code and figuring out what inputs.
No, but you can ask a vector. You can say to, and again, we're going to cover this in a future session, and we'll delve too deeply into vector. But you can say how big is this vector? How many things live in it? And then when you iterate over it, you say you can say for I equals thing up to vector.size. And so
thinking more about the types, going on the question about the types going into the vector rather than its size.
Yeah.
The compiler can't always. I'm assuming that
every variable in C++ has a type defined at compile time.
Yeah.
Right. So the moment you try and add a variable into a vector, the compiler knows the two types of the thing. It knows the type of the thing that should be in the vector, and it knows the type of the thing you're trying to put into it.
Sure.
Yes.
So there aren't any. Sorry.
Oh, no, go on.
So
I think Parvez was going to try and explain it to you.
There couldn't be any scenarios at all that could happen where you wouldn't get an error until runtime, or could there?
I think
always know, or
if you imagine you ask the variable for numbers and it gives you a string, you try and put it into your vector.
Sure.
Yeah. Yeah. So if you've got a vector of ints and you try and put a string into it, that's going to be an error.
Yeah.
Now you asked me, are there any circumstances in which you can get runtime type errors? There are, but we're not going to get into them for a very long time, and it can happen when you're basically trying to work around the type system using something called dynamic casts, and then you can get into a bit of trouble. But
so you can't actually have mixed types.
No, you can't. So yeah, a vector is just a collection of one type.
One type.
Yeah.
Not even if you do what's it called, a collection of a collection.
Yeah, so you could do a standard vector of ints.
Okay.
But then your contained type is another vector.
Yeah.
So it's like a 2D thing, like a matrix. So yes, as I say, we're going to delve into vector an awful lot more. I just want to let you know what it was, which turned out to be quite a good thing, if for no other reason than to tell you it's not a mathematical vector. It's C++'s version of an expandable array, like an array list or a list in Python or something like that. I'm going to tell you what these are as well, just because they might turn up in examples, particularly if you're looking at C code, and to tell you not to use them. So we've seen standard vector is this library type. It's in the namespace std. It's part of the library, not part of the language. C++ does have arrays built into the language as well, called C arrays or raw arrays or language arrays. So you'd see it as something like this, int ARR, and then you don't actually have to say the size, you can omit that. But
that's why the book doesn't go into them then, if they're not. Well, it goes in, when I was reading through it, it went into vectors first, and I was like, what about arrays?
Well, there's a very good reason for that.
Okay.
And it's this. Raw arrays are horrible and evil and
burn them all.
Burn them all, yeah. Do not ever use them. They behave in very, very strange ways. So if you're coming from a C background, you probably already know, they decay to pointers at the drop of a hat. And we don't really want to have to deal with pointers when we don't have to. Arrays are very strange beasts. You can't return them from functions. They're just horrible things. Raw language arrays. That's why vector exists. Vector is better in every way. So if you see an example online and it tells you to do this, that's not a very good example. There's standard vector. There's another type called standard array, which again we'll talk about in a future session. But vector is where you should go by default when you want a collection of something. Yeah, getting sage nods over there. All right. Any questions about language types, library types, types of types? No.
Question from something that you mentioned at the beginning. You said that parameter names to functions are optional. How do you refer to a function's parameters in the block of the function if the name is optional?
You can't. It's an anonymous parameter. Yeah.
What is the use of having an anonymous parameter if you can't refer to it?
Yeah, good question. They are necessary in some circumstances, but it's not worth going into right now. We'll get too distracted. But yes, you're absolutely right. You cannot refer to that variable if you don't give it a name.
You can find array in the library.
There's standard array, yes.
So we call the array the standard array.
Yes.
So no int array.
No, so I wouldn't worry too much about standard array. We're going to cover it in a couple of weeks. I'm just saying it's another alternative to these raw arrays. This is mostly for people who've read ahead in the book. People who have already read the book. So a standard array is another alternative.
It's correct to call like that. Int array.
This?
Yeah, I mean, is a...
I would say that this is I would call this a C array of ints, if I was going to refer to it. All right. Whew. When's the beer getting? All right. Let's talk about variables. What is a variable in a programming context?
Store for a value.
Container.
Yeah.
Store for value, a container? Yeah? This is my dictionary definition. A named storage location for some data. Does that sound reasonable? Yeah? So in C++, every variable has a type. We talked about that last week. C++ is a strongly typed language, statically typed language. Every variable has a type. And once that type is assigned, it can't change. And we call the data currently held in a value. We call that currently held in a variable. We call it its value. So if we said int I equals 0, and I is a variable, and the value of that variable is 0. These are pretty, well, that's fairly common, not every programming language, but a lot of them. But variables, typing, that's very common in probably most of the programming languages you've used. This one might be new. In C++, the lifetime of a variable is tied to the block, the scope, in which you declare it. And this, I touched on it last week, and I'm going to touch on it again because it's really quite important. Really one of the core concepts of C++. The variables only exist within the block that they're declared. And once you leave that block, that variable no longer exists. That variable is destroyed. I think the pizza might be here. So we can declare a variable. We can say type name. So for example, int variable name I equals initializer, initial value, 0 or 27 or 42 or whatever you like.
Do we have to do the initializer?
Sorry?
The last part.
You know the answer, so be
I know,
patient.
but I think maybe people will be interested.
So this is one of the ways to declare a variable in C++. Type name equals something. Make sense? Yeah? Don't know why. I've got to fix my slides so I don't get things disappearing when I go to the last bullet point. So some other languages you might need to use the new keyword. New is also a keyword in C++, but it does something a bit different. For normal variables, just things like this, you shouldn't say new. Okay? Just forget about the new keyword. Doesn't exist. But that's not the only way we can do it.
There is a question.
Oh,
How
sorry.
do you get the variable to live outside of the block? I suspect the block of the
yeah, in the parent block.
Yeah.
Yeah. So there are things called static variables that live for the whole life of the program, but they're generally best avoided. So we can write this same initialization in a couple of different ways. We can say int I, and then use curly braces and put the initial value inside the curly braces. Or we can do the same thing with round brackets. So 3 different initialization forms, with equals, with curly braces, and with round brackets. That's really annoying.
Confusing.
Really confusing. This is not great. So this one here with the curly braces, this was introduced in C++ 11 to try and fix this horrible mess of having lots of different ways of doing it. Unfortunately, they just made it worse. They just made it worse because there are situations in which all 3 things can have slightly different meanings. It's a nightmare. Initialization in C++ is a mess. Oh, I've gone back and I meant to go forward. So, which one to choose? Some of it's personal preference, tabs versus spaces, which one you just like the look of best. And my advice, except for special cases, prefer the equals form or this curly brace one. You'll run into fewer problems. So I'm going to mix up probably these and the equals ones. You'll see both in my examples. I don't have a hard and fast rule of when to use one and when to use the other. Very occasionally I'll use this one only when I have to.
Can you chain those all on one line for about 5 or 6 definitions in one?
You can. So you could say int I, curly bracket 0, comma j equals 9. You can even mix them up on one line if you want to. Yeah.
So rather than having int I equals...
Yeah, you don't have. You can declare multiple things on one line. You separate them with commas. Yeah, that's a good question. Oh, wow. I have absolutely no idea what's coming up on the next slide. This is exciting. So this is what Tom was asking. We are allowed to omit the initial value. We can just say int I. And at this point, the compiler won't complain to us, because this is a perfectly legal line of C++. But it's bad, because we're just declaring an int, and we're not saying what the value of this int is. And in fact, from a technical point of view, the initial value of this is going to be junk. It's going to be whatever happened to be in that bit of memory at the time. You've got absolutely no way of telling what it might be.
Can it be used to generate random values?
No, quite the opposite, right? this is what the standard calls undefined behavior. An undefined behavior basically means anything can happen. All bets are off. So the sort of cliched thing is demons might fly out of your nose. The computer could format your hard drive. Anything can happen if you try and read from an uninitialized value.
Can there be security concerns with
Absolutely can, and this is a a thing that comes up very frequently in C code as well, because it's even more common to do this in C. Yes?
In JavaScript, it's possible to declare a variable with a name that I don't see there, I just see the type. I know, there is a name, right?
Ah, yes, is the name.
And then as a global variable, and then you're going to use it down the code. And
but JavaScript gives all uninitialized variables the value undefined, so that doesn't have the same.
So this one
doesn't have the same.
No, so this has no meaningful value at this point. This could be absolutely anything, right? So the compiler could, if it wanted to, say, okay, if you don't give it initializer, we're going to set it to 0. But it doesn't do that because of silly reasons, frankly. The takeaway from this is always give variables an initial value. Sorry, you had a question.
It was kind of off the back of that. Why doesn't C enforce an undefined type?
So the sort of principle behind this is it's a sort of cliche with C++. You don't pay for what you don't use. So there are a very limited set of circumstances where, as a pure optimization, you would want to not initialize something and then further down later on say, okay, now put this value into it. And that's okay, as long as you don't try and read the value before you put something into it. And how to put this? Giving it the initial value has some cost in terms of computing time. It takes a fraction of a billionth of a second to do it. It takes longer than not doing it, right? So if you're doing this trillions of times a second, then people who care about very, very high performance care about this initialization cost. I don't care about this initialization cost, or rather the other way around, I don't care about it until it's important, right? So your absolute default should be to give variables some sort of default value. And then if you're really getting into things, and then if you're profiling your code, and then if you find you can shave off a few % by doing the dangerous thing, then maybe think about doing the dangerous thing. If it hasn't come across, I think C++ has the wrong default here, but that's just... how much... Right, I think I've got one more of these and then we can have some pizza. So this was coming off the back of someone was asking about trying to put the wrong type into a vector. When you supply an initializer, C++ will check that the initializer is, well, in rough language, compatible with, or strictly speaking, is convertible to the target type. So for example, we declared this f is a float, and we've initialized it with an int. So this is a whole number, so 3 is an int. But that's okay, because we can convert an int into a float without losing any information. On the other hand, we've got a standard string called str, and we try to initialize it with a 3.0, which is a double. And if you try this line, the compiler is going to say, no, you don't. You can't convert a double into a string. This program, this will refuse to compile. Unfortunately, sometimes C++ can be a bit too eager to convert one type into another. It will try really, really hard to convert one type into another. So for example, this is a perfectly legal line of code. So we've got an int, a whole number, and we're initializing it with a double. And you might get a warning, but you won't get an error. But what this is going to do is just going to truncate the number. An int can only store a whole number, and the whole number in this case is going to be 3.
Can you use int like with the function notation like you can in Python to truncate, if you want to truncate?
If you want to truncate, yes, but in that case it's probably better to use a function that is explicit to say standard floor or the floor of this value.
You mean better in terms of readability, with performances it should be more or less the same?
Performance will be exactly the same. This is right at the bottom. Sorry.
So similarly, if you define a function which is expecting to have an int returned and you ended up returning a float, would that work?
Yeah, it's going to do exactly the same. It's going to truncate it. Yeah. So I've said about conversions in initialization. This actually goes for whenever you try and convert one type to another. So in a return statement or in a function call, it's going to go through this conversion process or attempted conversion process. One way to guard against this is using this curly brace initialization form. So we've got 3, remember? We can say equals, curly braces, or round brackets. The curly brace form protects you against what are called narrowing conversions. So at any point, anytime you're throwing away information, the curly brace form will say, no, I can't do that. So if you try, this one is okay, but if you try doing it with curly braces instead, you're going to get an error there. That was what was supposed to be really good about this thing they introduced in C++ 11. But as I say, in many ways, it actually just made the program harder. Gave us another option, was more confusing. So, I think this is a pretty good time to have a little 5-minute break. 10? Yeah. 10-minute break.
Pizza break.
A pizza break. So if we all follow Richard to the kitchen, then we can come back and be full of pizza and very sleepy and not concentrate on the rest of what I'm going to say.
Sorry to stop.
Yeah.
I didn't understand the last bit. Why you give me error here?
Because this is one of the features of this new way of initialization, one with the curly things, that if it's a narrowing conversion, so if this would truncate to 3, then it says, okay, that was probably a mistake on the programmer's part. They probably didn't want that. So it tries to protect you from mistakes.
So it might be that this one, for a compiler, could be just 3.
This one will definitely be 3. Okay, so we're trying to say int I equals 3.9, but we can't store 3.9 in an int, because an int only stores whole numbers. So what it does in this case is it just throws away the 0.9.
Okay,
and this one
is like, okay.
It says no, you were trying. This is probably a mistake. So it tries to protect you from making mistakes.
So it's better, like, I mean,
the curly braces
in that respect,
in that respect is better. Yes.
How do you move on?
Now the cable, you see it doesn't get so far. There might be one down the other end.
I am in the middle. What is the password? D1GG?
D1GTY DMD.
Ah, DM, no M.
Long laptops.
Key quests.
Hello, everybody in Internet land. Sorry, we've been enjoying pizza. Well, sorry you couldn't have any, but it was delicious. Right, I'm going to have to do a quick bit of editing.
I took mine out.
This place is also amazing.
The office is incredible, isn't it? It's
amazing. Inspires creativity.
Yeah. I'm expecting. Did you see the music room they had there?
No.
So it was back in the kitchen area, whatever that was. They had a music room with keyboard and guitar and bass and drums.
I didn't see that.
And gym, built-in gym.
There's not in the music room.
No, but here.
So
of course.
basically, there's no need to get out.
There's no need to leave. Yeah.
Just say a couple of things because people wanted to say about license and so on. So I'll just keep kicking for a second.
Okay, I think we are mostly back. So welcome back on part 2.
Very brief part 2. It wasn't exactly 50-50.
Yeah, couple of things just to remind. Number 1, there is a piece of paper. Can you ensure that your name is on that page if you want to be on our website? So clearly spell your name and pass along. Otherwise, if I can't read it or your name is not on it, you will not be featured on our website. So I'm passing through. So please put it your name. The second thing I've been asked about license. So if not everybody heard it, what I want you to do is download the CLion from JetBrains.com, and then you can use it for 30 days at the beginning. Now, if you need extension to the license, send me an email. It's subject put CLion license, so I know it is referring to license. And inside the email, copy your email address and you put your name. So basically, I can just copy and paste, and I will email you back a license. The good news is, it appears that JetBrains will extend, and they give us straight away 6 months, right? Previously they were giving us 3 months. Now they'll give us 6 months straight away. But I need an email from you, and then I'll email you back, and I have to pass your details to JetBrains. Where you find my email address, okay?
It'll be on the last slides, which will be up on the screen as you walk out, so you can scribble it down.
Sorry. With JetBrains, with CLion, you can use Clang and you can use GCC, and I think from the latest edition you can use even the Visual Studio compiler.
That is correct.
Yeah.
Yeah.
So yeah, it doesn't really matter which one we use then for this.
So you're using Windows on that?
Yeah.
Okay, so Tom put the link in last week's round robin email. So you download CLion, and then you download the Windows version of GCC, which is called MinGW. And he gave the link out last time, MINGW.
MinGW, I think I did one before. It was just
Cygwin.
Cygwin,
Yeah, that's an alternative way of doing it, which I think CLion understands as well. But basically, you go into the CLion settings and you tell it where that is, and then it's very clever and it automatically detects the compiler version and everything. So for Mac, if you install Xcode, or specifically the Xcode command line tools, you'll get the version of Clang. On Linux, if you're using Linux, you probably already know how to apt get or dnf get or whatever to install GCC or Clang. On Windows, you can use Visual Studio if you've already got that installed. It is a several gigabyte download, or you can use the MinGW compiler, which has slightly better support for the latest C++ standards, and also you can't use the Visual Studio debugger in C Lion yet. So if you want to step through with the debugger, which we might have a look at next week, then MinGW is the one to use.
So that's all from me, and I'm passing you back to Christian.
All right. Well, now we're all full of pizza, and our concentration is waning, and we've got refreshments. Let's have a look at constants. Because they're pretty important. What is a constant? I mean, in a programming,
I'm constant.
a variable we can't change. Yeah.
I was going to say that.
Oh, sorry. I was looking in that direction first. I believe you. That's what you were going to say.
Me too.
Yeah. So a constant is a variable. What?
You said me too.
Me too. Yeah. Everybody knew that, right? Everybody. Yeah. Yeah. A constant is a variable that you can't change. And in C++, we say this with the const keyword. So we can say const int I equals 0. And when we do this, it means any time after this, if we try to change the value of I, the compiler's going to say no. No, you can't do that. So if we try to say, after this, if you try and say I equals 4, the compiler's going to say no. No, you can't change it because it's constant, it's const. So why do we want to do this? Basically, const, and what's called const correctness, helps reduce programming errors. It also sometimes allows the compiler to optimize things better if it knows its value can never change. You can put in. I'll show you an example. It can also put it in a different storage area in your library or executable, in the data segment. It can sometimes allow better optimization. But primarily, the primary goal is to reduce programming errors. So, oh, Jesus. I really need to learn how to use Keynote better, don't I? But the best guideline is to make your variables const by default. So the default in C++, if you don't say const, the variable is what we call mutable. We can mutate it, we can change its value. But it's better to try and make your variables const by default instead. Okay, so start off by saying const whatever, and then only if you need to change it, delete that const word. Yeah.
It shouldn't be a proposal to automatically create everything const and then mutate the const.
People have suggested such a thing, and it would unfortunately break all the tens of billions of lines of C++ code that already exist. But yes, const is great, and yes.
Is that safe to use a variable const in a program that probably we have billion and billion lines?
That's even better place to use const. Right? Because when you've just got a small program, if it's only 20 lines or 100 lines, it's easy to keep track in your head of which variables are which. Right? But when you've got millions and millions of lines, then it becomes you're looking at other people's code that you haven't written. And it's really hard to know, am I supposed to change this or not? What happens if I change this? Because if I change this and somebody else's code over there didn't expect its value to change, then it can break things, right? But by marking variables as const, the compiler makes sure you can never change that value. Right, so it's about safety. It's about making your programs, about reducing programmer errors.
About the radiation machine, do you remember? The sending for scans of the people? To know the story?
I can't remember.
I mean, safety. It's not only safety of your program, but literally even sometimes safety of people. Tristan doesn't remember now, but he told me a story a long time ago about. It
wasn't me, but somebody did.
It wasn't. Anyway, somebody. It's a very famous story that was scanning machine for the, you scan your body for bones.
X-ray?
X-ray, sorry, I was losing the word. And they done the calibration at the beginning very incorrectly, and it was sending the maximum dose or random dose, and sometimes maximum, to the person's body, and that actually, or was it for the cancer? Anyway, one of the medical machines was sending basically the maximum level, and it was killing people. So, the code which you'll be writing, it might have, serious consequences. So, type safety like const are very important. Imagine you're sending somebody for a scan, and you should get, let's say, 1 millionth of, let's say, radiation, and you get the full power of the machine.
I think that's an argument for initializing your variables, not for...
And keeping them const, possibly.
Well, const as well, but for variable initialization, that's yes, the X-ray machine that was giving people effectively a random dose. Yeah, that's great. Initialize your variables and you won't kill people. Well, you're slightly less likely to kill people. Initialize your variables and I won't kill you. Yeah. So to declare something as const, we say const type or something. Or just because this is C++ and everything has to be complicated, you can also say it the other way around. So if you see this in example code, if you see this in books or whatever, you see int const, you're allowed to say it the other way around as well. And people have endless arguments about which one's better. It's like tabs versus spaces. They go on east const or west const. People have endless arguments about this. I generally write it first, but either is acceptable. In fact, you can even put it in both places if you really want to. No, don't do that. But yes, I thought I'd better tell you that in case you happen to see it and wonder what's going on. Constantness is a property of the type. Right, so int and constant are different types. Standard string and const standard string are different types. Well, it's not a particularly important distinction at this stage, but it will become more important when we go and we look at pointers and references and templates and things like that. So it's just a little thing, little seed to plant in the back of your mind right now. The const is a property of the type, not of the variable. Can I repeat questions? Don't worry too much about that right now. How long have I got? 15 minutes. I'm going to make people happy now. C++ has type deduction, or C++ 11. It didn't introduce the auto keyword, but it changed the meaning of this keyword auto. And with auto, you can use it in place of the type name when you declare a variable. And when you do that, when you say auto variable name equals initializer, or any of the other two initialization forms, which are, oh, everyone's too full of pizza. With the curly braces or with the round brackets, yeah, you can use any of them. So when you say this, what happens here? Previously, we said int, and we said I is an int, and its initial value is 0. In this case, what we're saying, we're letting the compiler deduce the type of I from its initializer. So the initializer here is a 0, that has type int. So the variable I now has type int. So people who get very fed up with having to type standard string everywhere, rejoice. You can now sometimes say auto, sort of.
Can you have auto a return type for a function?
In C++ 14, you can declare the return type of a function to be auto, but that has some restrictions and isn't always a great idea. So for my examples, I don't use auto return types from functions. I will, however, use it for local variables from time to time.
Why do you think it's not a good idea? Because I know
return types from functions?
Yeah, to put auto as a return type.
Because it means that you can't pre-declare that function. Because it means the return type of the function is deduced from the return statements inside that function. So the compiler has to be able to see the return statements in order to know the signature of that function. So next week when we go on to talk about header files and implementation files and all of that, it means that if you have an auto return type, it basically means it has to go in the header.
I get an error or I get some other complication if I try to...
You can't forward declare or can't meaningfully forward declare a function with an auto return type.
So warning, error, or...
It'll be an error because the compiler will say, well, I don't know what type this returns, but I need to know because, like we said, every variable has to have a known type in C++. So auto doesn't mean any type. I still has a type that is defined at compile time. I's type is just deduced from its initializer. So if you use C#, this is pretty much the same as var. Does more or less the same thing. It just saves you, because sometimes you thought standard string was bad, you can get some really, really long type names in C++. Once upon a time, you'd have had to type standard vector, angle brackets, standard string, close angle brackets, colon, colon, const, underscore, iterate, blah, blah, blah. You get really, really long type names. And they introduced this thing, auto, in C++ 11, and it does save you a lot of typing.
Can you predefine the long type names? So that
you can declare aliases, yes, and we'll see how to declare aliases in future. Or type defs, as they're known in C. But auto's another way around it. Auto deduces the type from the initializer. And one of the nice things about auto is that if you use it, you cannot forget to initialize your variable. You cannot have an uninitialized variable of auto type. Can anyone think why that would be?
Because you can deduce.
Because you have no way of determining, deducing the type, yeah.
I didn't quite catch
it. Doesn't matter. Yeah, that's what he said, yeah.
Sorry.
Yeah, no, that's exactly right. Yeah. So every variable needs to have a known type. And if we don't have an initializer, the compiler has no way of knowing what type we set. If we just said auto I, the compiler's going to go, well, all right, what's I? Is it an int? Is it a string? Is it a float? Is it some random type that I haven't heard of yet? We don't know what it is. So if you use auto, then you can't forget to initialize your variables, which is pretty nice.
Can I use a bracket?
You can, yes.
Okay.
Yeah.
But didn't you say that the point or the biggest advantage of using C++ is the fact that it's strongly typed? So
this is still strongly typed, and it's still type safety. So I has a type, has a fixed type, it can never change. This type is decided by the compiler to be an int. And the reason it's an int is because its initializer has type int. Okay, so this is not dynamic typing. This is still a fixed type. It's just saving us from having to write out explicitly what that type is. This is completely equivalent to if I'd said int I equals 0 here. Okay, and the reason is because this 0 has type int. Sorry, at the back.
It wasn't
for me.
Oh. Using the same logic you used before is more costly this way. Because like it is more costly initialized this way because he has to check which kind of type is
more costly. I mean, it might cost you a fraction of a second in compile time, but I very much doubt it. It's probably not going to make noticeable differences to the time it takes the compiler to compile something, because it has to check the type anyway.
Yeah, but the mechanism to initialize, he has to check back and then initialize.
Okay, but remember what we were saying about conversion. So the question is this more expensive way of doing things, right? Well, even if you say int I here, the compiler still has to check whether this initializer is convertible to, whether it's compatible with the int type. So it still has to do some checking. So this saves it from having to do the checking, it just has to deduce the type instead. So it's work, but different kind of work, yes?
How would it, you'd have to be specific, wouldn't you, if you wanted it to be a long int, because it wouldn't be able to tell the difference between.
That's a very good question, yeah. So what if I wanted auto to, what if I wanted this to be a long int instead? Well, in that case, there are two ways of doing it. Probably what I would do, preferably, is actually explicitly write the type. The other way of doing it is, I didn't mention it, but there are a bunch of suffixes. So you can say 0L, and that is a constant of long type. So yes, if you wanted to say So this is going to deduce as an int, but if you wanted it to be a long, there are a couple of different ways of doing it. And one is that I didn't, as I say, there are ways of having numerical constants of types other than int.
So really quickly, it kind of feels like every time you write auto, you know what type you want it to be anyway. So why not just write that? If you write auto, you know that's going to be an integer. If you write a word, you know it's going to be a string. Why not just write integer or string? Why would you ever put auto?
And yes, so why would you ever write auto if you know what the type's going to be anyway?
Yeah, because you miss the compiler choosing the wrong thing, right? You've got one character, it could choose your number. It could be an integer or a character.
No, because when it has one character, it's a single quote, and otherwise a double quote for a string.
Yeah, but if it's a 0, it could be a character, right?
0 is a valid value for a chart. So don't you risk the compiler picking the wrong thing? Yes, you do, and that is one of the arguments against using auto. So what I was saying about this West Const, East Const thing, people argue about it. People argue about how much people, like, I'm talking like absolute experts, standing committee level experts, argue about how much auto is too much auto. And there's one school of thought that says almost always auto, right? You want to use it almost all the time, except in special cases like when you wanted this to be a long, for example. And the other school of thought is that, well, no, like you say, the programmer who's writing the code knows exactly what type he wants, or she wants, at the time they write it. So why not just write it explicitly? All you're doing is obscuring, so the next person who comes along and reads this code maybe doesn't know explicitly what type it is.
Unless you put a comment on the end,
at which point you may as well, yeah. But so there are two opposing schools of thought. And there is no real consensus at present. There are a few situations, we probably won't get to it in this first part of the course, we'll do it in the next one. There are some situations where you need to use auto when you use something called lambda functions. But yes, so for my examples, basically I'll use auto when it saves me typing and when it's clear from the context what the type is. That's my sort of personal approach to it. As I say, there are people who just auto everywhere. There are a few interesting type deduction rules. We've just talked about const. So auto will never deduce a const type. So here we've said I is a const int. But when I say I2, just because I suck at choosing names, if I say I2 is equal to I, auto I2, so we want to deduce the type of this thing from its initializer, it's going to deduce it as a plain int, not a const int. That's just one of the rules of this auto deduction. The reason for that is because, oh yes, we've also got this note. For future reference, when we get to talk about reference types in a couple of weeks, auto never deduces a reference either. But we can say const auto. So just like we can say const int or const standard string or const whatever you like, you can say const auto. So we could put the const keyword there, or there, and say, and then I2 would be const. Oh, so we've got another limit up in the bottom. So here,
that's better. Const auto const J2.
You'd rather it was the other way around?
Yes.
Well, tough.
Because otherwise you state const is auto J2. Yes? So in this way it says const auto, so the auto is const J2. But if you say auto const J2, you know that J2 is auto and it's const. I'm the East Const, you know.
That's going to be a long conversation.
Yeah. So, if anybody was thinking about coming to the pub later, I think Tom's just put you off because I spend another 2 hours talking about.
We're about to run out of time.
Yeah. We are. We've got a couple of minutes left, but luckily this was all I ate. Well, no, that's not true. I had tons more, but we had pizza instead, so that was kind of better, right? There is. I did prepare a lot more material on this, but that's fine, so we can push it back to next week. I did come up with some homework for you. There were a couple more exercises as well. So for this course, we use Sea Lion as our IDE. It's by this company called JetBrains. So Sea Lion is available on all the major platforms. As Tom was saying about licenses, they give you a 30-day or 1 month or 28-day, or something, basically a month's free trial. Yeah. You get a free trial, and because JetBrains are very nice, for as long as you carry on doing this course, they'll give you a license to carry on using Sea Lion. So it is a paid product. You have to set it up with a compiler. So on Windows, you have to tell it where the compiler is. If this all sounds a bit complicated, don't worry too much about it, because next week we're going to spend the first little part of the session making sure everybody's got Sea Lion up and running, making sure you can all use some simple examples. So we're not just using the online compiler the whole time, because that's pretty limiting. We want everybody to be on the same page and using the same software. And so, yes. For those who'd like to, chapter 3 of the book, page 83, or at least 83 in paper copy. I don't know if it's the same in the ebooks. There is a drill near the end of the chapter, and it's pretty good actually. So just go through and actually do some practice of writing a sort of a more in-depth program than you have done so far. So you've got to write a program that generates a form letter. So it's quite an interesting little example. So next week, didn't at all rapidly edit this slide in the last 2 minutes. We're going to have, as I say, the Sea Lion install fest. Everybody's going to be up and running with it. We also have, you might see on the website, we have like a disk image for people who want to, who are happy using a VM. We have this Linux image that you can run, and that's got all the dev tools installed as well. So if you'd rather use that, we can do that next week. We're going to cover the things that we didn't cover today. So we're going to talk about a bit about value semantics and if statements and control flow and things like that. And we're also going to talk about the compilation model. So I keep talking about this magic machine called the compiler. I haven't actually told you what a compiler is or what it does, or what you put into it, or what comes out of it. So next week we're going to go into a lot more detail about how that works. And that'll be much easier once we've got Sea Lion installed, because then you can actually see the different steps it's doing. So that's the plan for next week. Does that sound pretty good? Yeah, well, you're not going to say no, are you?
Do you know where we are next week yet?
Yeah, that's what I was about to say. Check the website, yes, because we're trying to see what's happening next week.
Okay.
Week after that, by look of it, Skills Matters have us booked in, and over 43 people already booked in. So if you go to the 22nd, yeah, 22nd, so book as quickly as you can. I mean, the more time we give to a place like Skills Matters, then the bigger chance we have we'll get the massive room rather than small room. Yes, so obviously we want the big room. And follow me on Twitter for all the most up-to-date things I'm trying to keep, with me being horrible at, the social media stuff. I do my best, so
yeah, there is actually a Twitter account for CPP London Uni, right? Unfortunately, it's run by me, and I am the most useless man in the world.
He's worse than me. That's true.
At social media. I'm like the last remaining human without an Instagram account, right? So if anybody, like Justin, for example, wanted to take over running the CPP London Uni Twitter and announcing to all these lovely people the news. I'm just looking at you because you're young, so you probably know how social media works. No, okay, well, never mind. Okay, I put up this slide last week, but for those who weren't here, there's a whole load of online resources. So ISO CPP is like the official homepage of the ISO, the International Standards Organization C++ committee, the people who define what the language is, the experts. They have this getting started page, which I think pretty much tells you to buy that book. CPPreference.com is a really
amazing website.
Yeah, it's very technically accurate reference documentation that unfortunately is a bit impenetrable. So it's very good for experts, but I'm absolutely 100% correct, but
go to examples at the bottom.
Yeah, not always the easiest to get started. It's on C++.com, which is another source of reference documentation, but it's a bit more approachable. It's not quite so dry. I mentioned this last week. Kate Gregory, if you don't want to listen to me, she's a very, very highly respected C++ teacher, does it for a living. There are a section of paid courses on this site if you feel so inclined. There is a free trial. She's very, very good. So if you want to have a look at that, there's
the slides will be on the website, so you don't. I mean, no problem. You can take the photos, but you'll get all that info as well on the end of the slide.
There's Reddit and there's the Slack channel, and anybody who's done any sort of programming will have come across Stack Overflow. Just beware the grumpy people who like to tell you off for asking what they consider silly questions.
Giacomo sent us funny cartoon about that. The job interview was, the cartoon was like 3 pages, three shots. The first one is like, so why would you like to work with us? And the guy said, that's a stupid question. And the guy, welcome. And above is Stack Overflow.
Yeah. Stack Overflow, lots of experts on there, not very friendly to beginners. That's what I say about it. Yes, and that's it. That's thank you for coming. Thank you to King for hosting us. The pizza and the beer and everything else.
Thank you very much. Thank you very much.
Yeah, there is more beer also.
Yeah.
Oh, that is literally the biggest cheer of the night. We don't know yet. Sorry, we'll let you know as soon as we can. So if you sign up on the website, as soon as we know, we'll email everyone around.
Sorry? For live listen, it's not live in the subject. Just put your email address and your name and surname into the email, so I can just copy and paste and paste. Thank you, sir.
Well done.
Okay.